Okay, progress report time. The set is actually working really well. So I may have been a little hasty in the previous video when I basically condemned all three picture tubes as being near the end of their lifespan. I mean, they probably are. The amount of adjustment I have for the brightness is pretty low. But this, it's very, very watchable. And all I've done is replace the rest of the electrolytics. I'll get to all that in a second. But I have this thus far, but I also have this.
Volkswagen. It's been called the most recognizable brand name. Maybe even the most recognizable shape in the world. Well, it's not hard to see why. Hi, I'm Jack Dalby. The Volkswagen Beetle with its putt-putt motor in the back, its utilitarian interior.
So we have audio. I don't remember if this is VCR is outputting channel 3 or 4. I think it's on 4 right now. But we are getting good audio through the section. I mean, it's pretty clear.
A synonym for quality and reliability that anyone could afford. So Volkswagen is the world's...
So that sounds pretty good. No video through, though. I checked all the other channels on there, played with the fine-tuning. The fine-tuning only affects the audio right now. But it does seem to be working. And there's a few things I want to check, because I have not touched any of the capacitors in the IF strip or anything else. But the fact that we're getting audio is very good, and it means there's probably only a few things we need to check to see where the video signal is going. So let me turn this off, and I'll show you what I'm talking about. Okay, so I suppose it's worth mentioning why all of a sudden do I have really good brightness. Well, the short and long of it is I replaced the rest of the electrolytic capacitors. I looked at the schematic thinking, God, what could go wrong with this? Was taking a look at the brightness section because I thought, oh, there could be something wrong down there. And then I had this little hint right here that shows there's a connection to B++ as part of the brightness circuit. And I thought, oh, wait a minute, I haven't really messed with that part of it yet, have I? I only replaced one of those electrolytics, the first one, the very first guy, right there. That's the entrance to the voltage doubler circuit for the rest of the unit. I did that, I did not do any of these, or that one. So, naturally, the next thing I did was I went back and I replaced all of those, and hey, what do you know, suddenly everything works correctly when it has proper operating voltage. This is actually something that was explicitly told to me when I was working on my very first TV, an RCA 9T246, which for a first television project was not something that would have been recommended. And I was having trouble getting anything to show up on it, couldn't get a lock. There were a lot of problems. The whole horizontal and oscillator stages needed a whole bunch of new mica caps, but I was trying to run the thing at less than standard operating voltage. And the general wisdom is, if you want something to be troubleshooted, if you want to be able to troubleshoot it correctly, you can't run it at less than the normal operating voltage and expect to get usable data from it. If you run it at only like 85 volts and it doesn't work correctly, that doesn't tell you much. You need to run it at whatever the factory spec. Like a lot of these tend to show like 117 VAC, I think, maybe RMS. So it's when I'm running it now, I'm doing at least 110 on the Variac, so that I'm eliminating any potential failures from low voltage. Because don't bring it up enough. Maybe one of the circuits doesn't oscillate correctly. Tube filament doesn't get hot enough. Doesn't produce light. Whatever. Trying to test something like this without it operating at the correct voltages is kind of pointless. That being said, let's take a look at what I did to get the other electrolytics redone. Okay, so here are the three main offenders. At the front, this is the 120 or 140 microfarad guide that provides the supply from the AC side to the first selenium rectifier. This guy here is a triple section that, let's see, what did it have in it? Well, it's got a 100 microfarad at 300 volts, a 60 microfarad at 150 volts, and a 20 microfarad at 25 volts. Those latter two are elsewhere. Let's see. So one of these is the main filter coming off the selenium rectifier. The second one here is for the B plus supply, so there's a B++ capacitor, a B+, and then this other little guy is part of a cathode bypass in the audio circuit, if I remember right. And then the guy down here is a 120 microfarad at 300 volts, which is the other filter capacitor. There is a 20 microfarad at 300 volts that I don't remember what it does. So that's just got 2 in it, 3 in it, and 1, and these are all on fiber insulated washers, I guess you could call them, because these are floating from chassis ground. They are separated. Now, normally I would just put the electrolytes on the underside, but because of the number of connections that these cans had going to them, it would have been a bit of a spaghetti mess for me to put terminal strips in there, and I didn't want to go drilling a whole bunch of holes. When I do the seleniums, I try to reuse those with small brackets to put the replacement resistor and diode or whatever on. Generally not enough room left over to start tacking electrolytics on there, because then you got to move all the wiring, and I kind of want to leave the lead dressed the way it is. So the way I do it is, well, first off, I try to remove the cardboard sleeve. If it's the insulated kind, they generally have a cardboard sleeve on them with the information stamped on the outside of it. These all have the Motorola script on them, by the way, which is pretty cool. So what I wind up doing is I use a heat gun on the top and sides up here to soften the tar that attaches that cardboard sleeve to the original can. Here is a remnant of the original can. You can see the tar on top of it there. This stuff is a pain in the butt to remove, and you do risk burning the cardboard a little bit. Mine's a little more black than brown up there than it used to be. But once you get it to break loose, you twist it a little bit and it pops off, and you're left with just the bare steel can. What I do after that, of course, I take a hacksaw blade, or more properly, the hacksaw with the actual handle. I prefer this kind, so you can actually get in there right around the base. Makes it easy to get to. However, I don't go all the way to the bottom. We pop the top off of this guy here. The can capacitors have a base that is wider than the center section, so the tube is only actually attached to the thing by friction at the bottom and by the tar on the top and top sides. So once you loosen that off there and you slice this off, I drill 1/16 inch holes next to each of the terminals on the inside, not the outside. And that gives me just enough space to pass 22 gauge solid core insulated wire through, and I drill an additional hole for ground. And then I can bring all those connections up to the new capacitors and get them set in place. Now, I know it doesn't look all that pretty. I've got electrical tape holding them together, but I had to do it like this for space reasons. Depending on how many values are crammed in there and how big the capacitors you buy are, you may or may not be able to get them all in there. I got lucky with this. These were the smallest Nishikons I could get for that value of around 120 microfarads at 450 volts. The rest of them were out of stock and had excessively high lead times, so this was the best I could work with. But because the cardboard tube remained intact, I can just stick that back over there, and it just seats nicely on the base at the bottom. The middle one here did not fare quite as well. I tried my damnedest to get the tar to loosen up, but most of it was actually around the ring, and I spent most of my time trying to heat the top, so I just got frustrated and slid it up the back with a knife. So there's the 3 that live in there, and yeah, this tube didn't do too well. I burned it pretty good. However, I have the junk set that has 3 good can capacitors on the top, so I'm going to try and salvage one from it, just so that this looks okay. But we've got the 3 electrolytes in this. There's a little 22 microfarad guy, a 68 microfarad, and then another 140-ish microfarad electrolytic at 450 volts. I also try to get the ones that are rated at like 10,000 hour lifespans, because you never know how long this set might want to be played. And then, of course, the last little guy, the one I did first, super easy. Only takes up a little bit of space. These fit nice and snug back on there, and they look good, except for that one because the top is gone. But that's all I had to do to get it to this point. And, oh, I suppose I should probably also show that, yeah, we got all the new high voltage caps installed, so those are all nice and insulated. Now, I did want to take a look under here, because I want to figure out which one of these capacitors is the 0.05 that comes off for the video circuit. So, there's a 6AU6 for the video amp. I'm going to guess it's towards the back of the set. Is it this one, or is it... Okay. Probably this one. Okay. Yeah. So the video amp tube is going to be about here. And the brightness control is the very last one here. Right next to the plug. Yeah. So this is the brightness control. And a 0.05, let's see, there's supposed to be a 470 ohm resistor that comes off the center tap. Here's the center tap. Where's that going? I like hunting around for this stuff. So that's going to this center terminal here. This guy right here is the 470k resistor, which means this guy right here should be a 0.05 capacitor. All right, so this guy right here is what the video signal is going to have to pass through from the 6AU6 to get to the brightness control and to the CRT. And in fact, we can see the CRT connection right here. So this is going to the cathode. And it goes through a small, yeah, there's a peaking coil or two there, and then that goes into the 6AU6 right here. So this would be my first suspect. The other option that I have actually is here. So, am I actually showing that up on camera? Sorry. So this is the video detector section. So we have the last two IF amplifier stages here. We don't care about that because I know if I'm getting an audio signal all the way through this thing, the video signal has got to be there too, because this uses an intercarrier system. The IF is passing both the video signal and the FM signal through all the way to the end. In fact, the FM audio signal isn't picked off until right here on the output of the video amp tube. So the video signal is going down this way. The audio signal, the FM modulated signal, is going up to this little coupling cap here, and then goes off the other way and eventually makes its way around up through here to the ratio detector and then to the speaker. So if I'm getting audio here, that means all these stages up to this point are most likely tuned well enough for that signal to appear. However, if we're not getting a video signal, there's really only two possibilities. Either A, this cap down here that goes to the cathode from the video amp tube is really weak or exceptionally leaky, and we're just not getting a strong enough signal through for it to show up anything. That's a possibility, but if all the other stages are working more or less okay, that would be probably my second guess. My first guess would be this guy right here. So this is a very early 1N34 germanium diode that they're using for the video detector. Instead of using like a 6AL5 to do the demodulating, they are actually using a semiconductor. And this guy is inside of a small box on the top of the chassis. So what I want to do is pop that off and double check the continuity on this. Because if that's dead, we won't get a demodulated video signal, and that might explain why I'm not getting anything on the screen. So I'm going to take that off, and we're going to see how this thing tests. And if that doesn't pan out, then we'll replace that cap and see where we go from there. Okay, so this is the guy I just undid the hardware for. Okay, there's a little insulating sleeve in there. I don't want to lose that. And there is a bit of a mess of components tucked inside. Let me rotate this around. So we can see in there. Alright, so that's our video detector assembly. Where's my pointing device? I want to know. Oh, okay. So the 1N34 is actually this guy right here, and it appears to be encased in a little piece of clear plastic. Still a little bit flexible. That's a pretty big diode. Looks like it's a Sylvania part. So it's going from this lug here down to this lug right here. So that means I need to grab my meter, put it in diode check mode, and see what we got. Pause on account of meter being walkabouts again. Alright, let's see. Great, we've got it on the annoy-o-matic mode. And I can't... Let's see, the black band is facing toward the bottom. So... hopefully nothing else is in parallel with this that would throw it off, right? So I'm getting some small reading, or I was briefly getting some kind of small reading there. Alright, let's try the other direction. Okay, so we got 359 that way. And 1900 that way. I would say that's probably pretty good. Okay, so video detector diode may not be the problem, so I'm going to temporarily slide this back on here. If I can get the paper to behave. And we're going to flip it back over, and I will grab a spare .05 out of the bin and put it in there, and we will see what it does. Okay, so my initial prodding around with the diode, or the detector circuit, didn't seem to do anything. I would probably have to take it out of circuit to swap in another one to see if it actually changes anything. After looking at it for a second, I decided I'm going to do one other little test to see if I can't get it to function. Oh, for God's sake, I didn't even turn the Variac on. As I was saying before, I forget to apply power to the set. What I'm going to do is I've got the VCR unhooked from the coaxial connection of the antenna. I am going to turn it on, though, because it has a composite out, and I'm going to cheat and try to inject a composite signal, damn it, directly before the video amp. And assuming that the video amp and the synchronization circuits, or we got an image there, are all working the way they should, then technically I should get an image. Now if I screw up the polarity, I might get a negative image. So let me turn that off here. I was wondering if maybe the vertical linearity was a little off, but there are no vertical linearity controls on this thing, so there's not much I can do about that. So let me hit the play button here. I'm also trying to remember. That's not too confidence-inspiring. I mean, the image is well, it's doing something. Hmm. It almost looks like we've got a little bit of vertical roll going on. Let me take a look back here. Wait. Ah! There be an image. Come on. Alright, it's freaking out a little, so it's trying to synchronize, and it does look like I have the image reversed, so let me swap these around. So I'll put this one here, I'll put this one here. So that's vertical lock. Oh, there we go. Well, almost. Getting pretty close. Come on. All right. So yes, we do have... Am I actually showing that on camera? Yeah. Okay, so we do have an image. That's good. Contrast control looks like it needs to be cleaned. It's freaking out. Yeah. Ooh, briefly saw the... Okay. Now I don't have any audios because I disconnect the coax, so the audio section's not getting anything. That's not what I'm interested in. I'm interested in why I'm not getting the video signal from the RF section through to the video amp. Now the question is the problem at the detector stage, as in the diode itself is dead, or is the problem somewhere in one of the previous stations? Let me take a look at the schematic here and see where else I could potentially jab a video signal into that wouldn't involve plate voltage. Let's see. Video signal is coming off the cathode of the 6AG5 third IF amp. That's going to be plus. The problem is I can't... injecting a composite signal like I'm doing right now, it tells me one thing. It tells me that the sync circuits will work and that the video signal can make it from the video amp tube through to the picture tube. That's all well and good. It's not telling me if the actual video detector is working, because the video has already been detected. The output from the video detector is a composite signal with the video information being an amplitude and then the sync pulses being in there. And that gets picked up and sent off to other various parts just for the circuit to drive the horizontal and vertical crap and all that. So what I would have to do is put in a modulated signal in there and have it actually decode it. But that would require me to input that signal at the intermediate frequency of the set rather than the frequency that this outputs for channel 4. I don't have the equipment to do that. So, oh crap. Alright, but at the very least it tells me that the video detector is working. It just doesn't tell me how far back the issue could be. Again, it could be that the 1 in 34 detector is crap. That's entirely possible. Part of me also wants to just go through and replace the rest of the wax capacitors. I normally do that anyway. Damn. I wouldn't think the audio signal would be able to get all the way to the end there without the caps being at least somewhat good. The video signal should have come with it. I think the easiest thing to do is just going to be to swap out the 1 in 34 and see what happens. You never know. Yep, I think I'll do that. Okay, so before I move on to my next bit of tweaking with this. I did try swapping out the detector diode. I couldn't find any of my really, really old point contact germanium diodes to put in there, so that was a bit of a bust. I tried swapping in a 1N4148. I have some smaller silicon diodes, but they won't behave quite the same. And honestly, I got the same results with one of those in there as with the original 1N34 in circuit. So that didn't really tell me much. So I'm gonna fiddle around with some other things, check the schematic out, probably check some resistances, and see what else. But yeah, it's kind of getting down to the point where I'll probably have to look at doing an alignment on this, potentially.
And the German Autobahns, which often have no speed limit, made high-speed handling and road holding.
Okay, I managed to get it. I didn't actually do anything special. I kind of panicked and I went through and I recapped everything. Just got all the other wax capacitors out of the way. Mostly because, for me anyway, trying to diagnose something that still has potentially faulty components in it is kind of a waste of time. It's much easier to get rid of all the unknown variables, put in good known components, and then look for trouble afterwards. And since replacing all the wax capacitors and all the electrolytics, and I checked a bunch of the resistors and the IF circuits, and everything checked out fine, it didn't really make sense that I wasn't getting video through, but I was getting audio. So I kept looking over the schematic, and I was looking at the antenna input connections, and I realized that the balun the matching transformer I was using, I had on the two antenna terminals. There were 3 terminals on the back, an antenna, 2 antennas, and a center ground. And the schematic shows that the 2 antenna connections, if you attach across those, it's about 300 ohms. If you attach from ground to antenna, it's about 75. I actually need to see which one I'm using right now. I think the lower terminal. Yeah. But point being, most of these baluns I want to say were set up for 75 ohms, so on a whim I swapped the connections over and then just started playing with the controls, and remarkably I actually got a picture. Now it's not great. What I'm seeing right now is, I don't know if you can tell if I turn the volume up just a little bit. It's hard to see in this scene. There's a bit of random flickering lines in there. But when there's less bright images on the screen, the whole image flickers when there's audio playing. So it looks like we're getting a little bit of bleed over of the audio into the video circuit. And honestly, I don't know how to get rid of that because the audio pickoff is all the way at the end, right after the video amp tube, and I'm not seeing a trap. I mean, there's a few coils there, but they're not adjustable or anything. So, just a little curious. Neither inductor 58 or 59, they're both fixed. Either way, I mean, I guess it's not a high-dollar TV by any means. But as far as controls go, one thing I did have to do was, I thought I had this thing set on channel, or it's got like a channel 4 output, and we lost the picture. Oh, there it is. That might be components heating up and linking around. But I've got it all the way up on the last channel there. And I've got the fine-tuning control set to about where I can get the best picture. Okay, shut up. That's about as good as I can get it for right now. I imagine I'd probably have to do an alignment on this, which, having looked at the instructions, they don't give any alignment data for if you're just using like an AM signal generator to peak some of the coils like the airline did. They actually want you to use a sweep generator with the ability to inject multiple markers. I don't have equipment like that. I can inject one marker at a time. I can't do more than one, though. I mean, I could technically, if I had an additional adjustable or frequency. What am I trying to say? If I had another variable frequency oscillator that could do up into the megacycle range accurately, and I could measure it, then yes, I could. The problem is I don't have anything that can reliably measure whether the output from the generators I have is actually what is required for the set. That's one of the problems I'm running into right now, why I couldn't really align the airline the way it was supposed to be, is because I have frequency counters, but they're only good for lower frequencies, and most of the ones I have won't pick up the signals coming out of these generators, and if they do, they're all over the map, and since I don't know when the last time they've been calibrated is, I can't really take them as well. I can't really take the data they give as gospel. Ultimately, I'm really just going to have to break down and buy a digital oscilloscope that has frequency measurement built into it, because I'm so used to using those, and they're so much easier to work with when you just need to know what a signal is right now. And yeah, I really just had to go with that. Either way, oops, still do that. But I've got this all the way up on the very first channel, which I want to say is the 2 to 3 range. Now, if I move it down to where I think is supposed to be channel 4, we can pick up the audio and we can kind of pick up a little bit of the video. So if I flip it down here, it looks like it wants to lock, but it can't quite get it. It just freaks out. Go back up to here and find the happy spot, and there we are. Again, not perfect. The contrast control, I really need to clean it because it's part of the last stage in the video amp, and it screws with the horizontal and vertical lock really badly. Actually, I can show that. So yeah, if you twitch it, it really messes with things, and I'm trying to make it so that I can get rid of most of the retrace lines. I don't like looking at those, but twiddling with it really does not help. And we're still getting a ton of those little audio squiggles in the video feed, which they're rather obnoxious. And I was getting them in the airline for a while, and then that problem disappeared. I don't know what the deal with that is. Might have to ask the guys on the radio forum what the deal is with this. It may just be, again, I just need to align it so that the IF and the audio and the video signals are separated at the appropriate number of megacycles apart from each other so that they don't interfere. Either way, I think this is a great spot to at least end the video on. For this TV, at least, this is probably about as far as I'll go for right now. Got some other things I'm working on, and I've got to order supplies for the airline again, since the last batch I had got stolen. So, until then, thanks for watching. Not sure when I'm going to get into the other VT-71s. I'd love to do another one, but these take time, and the components aren't super cheap. I have plenty of picture tubes now to work with, but since the electronics are working, I'm going to set this one aside, and I'm going to bring something else off the shelf that I have parts for, and I'll show you that here soon. But until then, thanks for watching.